In this video, we're going to do some problem-solving questions involving right-angle trigonometry and angles of elevation or depression. When we're tackling a problem-solving question like this, the first thing we need to do is underline or highlight some key information. A helicopter is hovering at an altitude of 250 meters. The angle of elevation from the helipad to the helicopter is 35 degrees. Find the horizontal distance. Second step of problem solving is to draw a diagram of the situation. One would assume that the ground is sitting at right angles to where the helicopter is. So let's just draw a helicopter. Here's the helicopter. I'm not going to try and draw, but that dot represents the helicopter. And the ground is sitting here at right angles. Now, the horizontal distance is what we need to find, and the helipad is over here. So this is the helipad, and this is the helicopter. So there's the horizontal distance, and that is what we're going to find. Now we've also been given the angle of elevation from horizontal. Angle of elevation goes up. So let's draw that line up there, and let's put that angle in. So angle of elevation is 35 degrees. So basic right angle diagram. So now I also have the altitude of the helicopter, which is 250 meters. Let's have a look at labelling the triangle that I've had. 250 is opposite the angle of elevation. The side that we're trying to find, the horizontal distance, is the adjacent. Looking at the word SOHCAHTOA, if I was to write that down, which ratio will I be using? The one that involves the opposite and the adjacent is our tan ratio. So we say that tan 35 equals the opposite divided by the adjacent, which is what we're trying to find. Rearranging x over there, tan 35 down there, we get that x equals 250 divided by tan 35. Typing that into my calculator, I get 357.04 to 2 decimal places. And of course, our horizontal distance has to be in meters because that's the unit that we've been given in the question. And now on to our second problem. We have two unidentified objects are being detected. The angle of elevation from the detection is 39.48 to each object, so that's important. The objects are hovering at a direct distance. The direct distance is important, of 826 meters and 1.296 kilometers from the detector. Find the difference in height between the two objects. So we need to draw a diagram of our problem. We have two unidentified objects, this one and this one will do, and they are at direct distance from a detector. So here's the detector here, and here's object 1 and object 2. Now we've got a direct distance, so direct distance there, direct distance there. We also have angle of elevation. Remember, angle of elevation is always taken from the horizontal. So here's the horizontal. Angle of elevation looking up at the object is 39.48. And again, from the detector looking up at the first object, same angle, 39.48. We've also got the distances. Now, the first distance is in meters, which is 826 meters. But the second distance is in kilometers, so we need to convert that to meters, which is 1,296 meters. Now, the object, again, we make this assumption, is hovering above ground level, directly dead below, sitting at right angles to the ground, and again, perpendicular or sitting at right angles to the ground. So we have two right angle triangles. Now the question's asking us to find the difference in height between the two objects. So we need the height of each object, and then we'll find the difference between them. So let's first of all focus on object 1. If we look at the height, that's opposite our angle. And the other information that we have is the direct distance, which is the hypotenuse. Let's look at what ratio we'd use against the word Sokotoa. So, oops, nearly spelled it wrong. Opposite and hypotenuse, we're going to be dealing with the sine function. We want the opposite. So opposite is the hypotenuse multiplied by the sine of the angle. So opposite for object 1 is, I'd rather actually write the hypotenuse first, so let me just scribble that one out. What am I doing? Sorry, have a moment. Opposite is what we're trying to find, 826 multiplied by sine 39.48. Type that into the calculator and that will give us this height here, which I've already done. That gives me 525.178 and so on. Now, you might write the rounded answer there, but don't round. You should never round up until the final answer is given. So just make a note of what that is. Let's have a look at this height here. Let's label. Again, we've got the hypotenuse we've been given and we're trying to find the opposite. Sine again, exactly the same ratio that I'm going to be using. So we want opposite 2, which is now 1296 multiplied by sine 39.48. Typing that into the calculator gives me a distance of 824.01. Again, rounded. Now we keep that answer in our calculator and we subtract because we want the difference in height of our two objects. So one distance, the larger distance, which is this one, subtract the shorter distance, which is this one. Difference is 824.01. Take away the 525.18, I guess, if we're rounding, but don't round until the end. Gives us a final distance of 298. I think I'm going to just manage to write this down at the bottom of the page, 298.83 meters. So if we were asked to write that to the nearest meter, doesn't say so in the question, but if you were, you would say that was 299 meters difference in height.